Hello! Today we're thinking about electron dot structures, or what we'll also call Lewis dot structures, and ions. And so we got interesting thing going. First, we got to remember valence electrons. Remember, valence electrons were from the outermost ring, or the outermost energy level in our electron configuration. So on that Bohr model, it was the outermost one, the ones that had the highest energy level. So how many were on that ring? Well, remember for sodium, we said they'd have 1 valence electron. Aluminum would have 3, bromine 7, and neon 8. Remember, 8 was the maximum we could have because the S and P electrons were on the valence level, where D was always a level lower and F was always 2 levels lower. So those were never going to be valence. So S and P electrons on the highest level are valence. And so an interesting thing that tends to happen is we can think about how atoms are stable. One way that they're stable is the neutral atom with this number of valence electrons that we've talked about so far. The other way is if they get to an octet. Octet means 8, of course, like an octopus. Oct means 8. And so if they get to having 8 valence electrons, like noble gas, for instance, which already has 8 valence electrons, there's some additional stability there. So what we can say is that atoms tend to gain or lose electrons in order to get 8 valence. And so we can think about here, the ones over here, all these ones in blue here are the metals again, and metals tend to lose electrons, where nonmetals tend to gain electrons. Both of them are going to do that to get to 8 though. You might say, well, if you've got like aluminum, which has 3 valence electrons, how could that lose electrons and get to 8? Well, remember, what we're doing is we're losing electrons from our outermost level. So if aluminum has 3 valence and we lose 3 from the valence level, or the outermost, then that level is gone. And so aluminum, if it loses 1, 2, 3, it now looks kind of like neon with its 8 valence electrons on the second level. And so therefore, if you're losing electrons, losing valence electrons to get to 0, or gaining valence electrons to get to 8, either way, 0 or 8 kind of means the same thing. And so the metals that tend to lose electrons are going to form positive ions, and those positive ions are called cations. I remember it because I think cats are a plus. If you don't like cats, then find your own way to remember it. I think cats are a plus. So cations are positive ions. Again, remember they're losing electrons. I know this feels backwards, but remember electrons are negatively charged. So in your life, if you lose some negative things from your life becomes more positive. So likewise with electrons, if the atom loses negative electrons, the atom becomes more positive. So that's a good way to remember that. So cations have lost negative electrons to become positive ions. Likewise, anions are negative ions, and so that means that they have gained negative electrons. And so usually those are going to be our nonmetal atoms. Nonmetal atoms. What we're going to do to distinguish between the neutral atom and the anion is we're going to put an IDE ending at the end. So it's fluorine is the neutral atom F, fluoride is the anion. With cations, we just use the same name, but sometimes we'll say cation after it. So sodium atom, sodium cation, just for naming purposes. We can look at these and we can think about the charge on each of them. If we remember our first column, group 1 had 1 valence electron. Having 1 valence electron is a lot quicker to get to 0 than it is to 8, so it's going to lose 1 electron and become a +1. Likewise, group 2 had 2 valence electrons. It's going to lose 2 electrons and be a +2. The middle, that D block, or the transition metals, those ones most of them have a +2 option because technically they all have 2 valence electrons, with that S2 being their valence. However, the D ones kind of mess with it sometimes. So sometimes they can only be a +1, or it can be a +3, or it can be maybe multiple options, like iron can be a +2 or a +3, and copper can be a +1 or a +2. Chromium could be a +2 or 3 or 4 or even a 6, I think. So they're kind of different. We'll talk about those more later. For now, we won't worry about them too much. In group 3, we have 3 valence, and so that could be a +3. In group 4, we've got it tends to go the positive way because most of these down below the staircase are metals. Those tend to be a +4. Carbon could be a -4 sometimes, but we won't see that real often. Most of the time we're going to say that's +4. This group could be a -3. Some of these big ones at the bottom here that are below the stairs, those could be a +5. Technically, we've got 6 valence over here. These are pretty much going to all be a -2. Maybe polonium way at the bottom might be a +6, but most of these are going to be a -2, and then a -1 along here. They did slide hydrogen over there. Hydrogen it's generally going to be a +1, but once in a while we'll see it as a -1. And then, of course, the noble gases already have 8 valence, or a full valence level. Helium has 2 because the first level can only hold 2, and so those do not form an ion. They are non-reactive, and so that's because they already have their 8 valence. So we'll think about that. We're going to write these valence. We don't want to draw all the circles all the time on the Bohr model. The really important ones are the valence electrons. So we're just going to put the element symbol in the middle with some dots around it. And this is called the Lewis dot structure, or electron dot structure. Means the same thing on those. So here, try a couple. Quick look at your periodic table and figure out how many dots to put on each one. How many valence electrons? Pause the video and try it. Hey, great job. Yeah, you're right. Chlorine should have 7 dots. Calcium should have 2. Germanium's going to have 4. And sulfur is going to have 6. And then the ion that's going to form, so chlorine having 7 is going to make a -1. That we call it chloride. Calcium having 2 valence will make a +2, be the calcium ion. Germanium is going to be a +4. Call that the germanium ion. And sulfur is going to be a -2, having gained 2 electrons, and that would be sulfide. Excellent. Moving on, we think about how it becomes a cation. Again, we kind of talked about this. Sodium's going to lose 1 electron, and then it's going to the level that was valence is now gone, and so the level below that now has 8 valence. So it seems weird that we had 1, we got rid of 1, and now we have 8, but remember, we're losing an entire level, and now the one below it is the valence. Same with calcium. It's going to lose 2 electrons to then have 8 valence. Bromine's going to gain 1 electron. Since it has 7, it'll make 8. Selenium's got 6. It's going to gain 2 to make a -2 on that. So give those a try. One more check here. Write the electron dot structure and predict which ion forms. Pause it, give it a try. Hey, nice job. You got it. Yeah, magnesium's got 2 valence, so we do 2 dots. That's going to lose them to be a +2 ion, the magnesium ion. Oxygen has 6 valence, 6 dots. It's going to gain 2 to be a 2-. Arsenic has 5 valence. 5 valence, so it's going to gain 3 electrons to be a -3, and that would be arsenide. Bromine has 7 valence. It's going to gain 1 and be a -1 bromide. Lithium has 1 valence. It's going to lose it to be a +1, the lithium cation. And neon already has 8 valence. It is not going to form an ion. We could say neon 0. It's there already, so we're all set. Go ahead and give the practice a try, and have a great day.